Let me also explain about this concept, why Docker. Like we are facing problems while deploying the local code, local application to the server, because it has a lot of dependencies related to the operating system, related to the different softwares. So, like sometimes when we are working on a project, what we say that in our local system we have, suppose we have node version, particular node version, that is node version 12, and we are successfully running our application into that particular node version. We have some dependencies like in the operating system related to that application. That can be anything, but whenever a client wants us to deploy that particular application onto the server, what happens? We always say, my functionality is working on the local host, but not on the live right now. We always say like these kind of conditions, and we face these kind of issues. So Docker is providing such kind of solution to this particular problem. Not only this particular problem, we have one more concept here where Docker is providing like a solution to a problem. The problem was, suppose we are working in an application which contains a very large scope, such as we have done a project previously. We have some developers here who worked on that particular project, that is Superior CS. So that project, I'm going to give you an example which we have faced actually. In that project, we have a lot of modules that is related to the chatting, related to the CRM, related to the invoicing. Due to that, due to microservices, we found a solution that if we have a CRM module in our project, or we have a chat module in our project, so we are keeping them separately with each other. And if there is a bug in CRM module, or there is a bug in the chatting module, then it is not affecting the another module. So that was the main benefit of the microservices. And like yes, when we are talking about the microservices, then we should know how to configure them into the machine. So to configure microservices, we were installing the virtual machines in our main system. So what is exactly virtual machine is? Okay, when we are going to run microservices on the machine, we have to configure a virtual machine into our system. What is exactly a virtual machine? Virtual machine is a copy, we can do one thing. If you have Windows in your system, we can install a software that is called a hypervisor, and into that software, we can install any of the operating system. If you require Linux for your application, if you require Mac for any Ubuntu for your application, you can install that particular operating system into that virtual machine. And after the operating system, that is completely a fresh machine actually. And into that fresh machine, you can configure your module, you can configure your application which you have splitted. So you can configure your application 1, application 2, all the dependency files which is required to run that particular application into the virtual machine. So that was the previous concept which we were using as microservices to overcome the issue to run large applications. But what was the drawback? Drawback was whenever you are installing operating system into the hypervisor, it is taking a lot of space, a lot of memory, and yes, it is obviously very heavy to run an application into a single virtual machine. And it is very difficult to switch between the virtual machines on the same time. So there were so many drawbacks. After these all drawbacks, we have a solution in the form of Docker. Docker is providing a solution for this particular problem also, to run the large application into a single platform. So what is Docker doing over here? Docker is also using a particular system. Docker has infrastructure. Docker is also taking our host operating system as a base operating system. But instead of hypervisor, Docker has its own engine. What is Docker Engine doing? Docker Engine is copying the base files of the host operating system, such as the kernel file, all the necessary files only, not the entire operating system. Docker is copying those files into the Docker Engine, and then the different dependency, you can install the different dependency files into the Docker Engine. We can say a container over here, image over here, to that particular engine. So Docker is doing what? Docker is creating an image of the host machine with the just required files of the operating system. That can be kernel, which is used to communicate between the hardware and the software, and the other dependency files, and we can deploy our application into those images only. So it is very lightweight, it is very easy to manage those images, it is very easy to switch between images, it is very easy to identify the issue occurring in a particular image, so that we can do these things. The like if your application is down, so we can do these things very quickly and easily. So this is the exact um, solution provided by the Docker for the large application also. So over here, we are using Docker for mainly two, not mainly two problems of the Docker developer, which is faced by us in our real life, in our day-to-day life. That is what, when we require to deploy large application, and we require to deploy them into small chunks to make sure the performance of each module should be very good. And the other thing, if we have to escape the all the challenges when we are deploying the application into the server regarding the dependencies issue. So this is exactly the difference between the virtual machines and the containers. I have used a term over here, that is containers. Containers are nothing. Containers are actually behaving like a virtual machine. I'll explain a lot about it in the upcoming slides. So this is one more example of the structure of our microservices in the Docker. You can have a look that we have to download a particular software if you want to use microservices. So I have just given a sample, that is VMware, and we have installed that VMware onto the server. So VMware is doing what? VMware is creating multiple virtual machines from the operating systems, and then multiple application can be deployed on the different virtual machines. But on the other hand, on the Docker, in case of container, we have a software that is Docker. It is also installed on the server. It is taking the files of the host operating system and all the necessary files only. And after that, it is creating multiple containers for our requirement, and we can deploy multiple application into the multiple containers. So these are the structure of microservices and the Docker. So next is how to install Docker. So Docker have a lot of configuration for each of the operating system. So this is a very important part over here. Like if you're using Mac OS, then obviously there is a Docker desktop, and if you're using Windows also, there is a software provided by the Docker, that is Docker Desktop. We can directly install the Docker Desktop application into our system and configure them accordingly and start working on our thing. But for the Linux, they have the Docker engine separately, and you don't have the flexibility to work on the desktop version, on the GUI version of the Docker. You have to work on the command prompt for the Linux. So let me show you. So from here, you can just download your Docker desktop for the Mac and for the Windows. And remember one thing, all the Window users, they have to check the system requirements and follow each step one by one perfectly. If you're going to skip any of the steps from here, which is mentioned by them. So obviously you will face a lot of problems while doing stuff with the Docker. So keep this in mind always, that you follow each and every step, and make one thing clear, that you have to install all the dependencies in your system to do so. And for the Mac users, you don't need to like um, keep much things in your mind. We have to do one thing. We have to just check the version of the Mac OS, and then you will download the DMG file directly from the Docker, and you can move that to your applications, and then you can just start using the Docker application. And similarly for the Linux, you can just directly go to the link, and you can just directly like follow the instructions. Along with that, if anybody, in case, I know all are developers, and I don't think that all have the like old computer with them. So if somebody have the old system, then they can download this toolbox. But this is no longer supported by Docker now. You can just go to the GitHub repository and download the repo from here completely, and make us like you can play around the Docker. But it is not recommended, because this is not supported by the Docker anymore now. And other than that, if somehow you're not able to install Docker into your system, you can just directly play with their concept. They have provided a lab session live. You can just directly log in with your credentials into the Docker, and you can just play around the containers and the images and the other things from here. After that, okay. After that, we have the concept of Docker images and the containers. So now this is the building blocks of the Docker. This is the main concept of the Docker. We have to clearly understand what a Docker image is and what is a container, and there is a difference between the image and the container. So Docker is consisting of two main things, that is image and a container. Image is what? Image is just a copy of your operating system, where you are configuring the requirements for your application. You suppose you want to run an application in the backend which requires Node version 15, Node version 14, Node version 18. You can create an image with the help of the with the help of commands. You can create an image, and you can just instruct Docker that you have to create image for Node version 14. After that, you have to like create a working directory. You have to do this thing. You have to do this thing. So we have to just instruct the Docker that how an image should be created. So we can say that it's just a blueprint, like it's just a template for containers. Like your containers should contain these kind of settings. So we are doing all the settings part, all the requirement part, all the dependencies part in the images itself. And after that, we can we can say the images contains the code for the containers. We can do code in the images. Like what we have to do is, we have to code our application first. We have to create the image from our code, and then like we can run container from that particular image. So container is actually what? When we have done with the images, creation of images, we can run an image, and the running environment of an image is called container, simply. So we can say that this is actually our application. We can communicate with our application. We can see our application with the help of the containers. How to create images, how to run images, how to like work with the containers. So, okay, I have created a sample project over here related to Node, in which I have just installed two dependencies, that is Express and body parser, and I have configured only this thing, that like this particular project is listening to port number 80, and I'm just taking the user goal, what we are doing in this particular session. So let me show you. So this is the current node project without Docker. This is doing what? I have this predefined value over here. If I enter anything here, that can be set to this particular label. And now let us start to configure a Docker file. So let me just create a Docker file in the root folder. Docker file name should be proper. It should be started from capital D and in the continuous format. This is a Docker file, and I would suggest you can install the extension for the syntax of the Docker file. You can install the extension, that is Docker, which I already installed. This one. So you can install this extension to work with the Docker files. So for the Docker file is what? Docker file is the instruction to the Docker to create an image. That's it. So if we are going to create an image, we have to do what? We have to create a Docker file from the existing images. We can do this. How? Okay, we can Docker Hub. So we can search for a particular image from here. You can just log into your account as well, and according to that you can do what? After account, after login into your account, you can just go through the multiple existing images into the Docker Hub. As I have created a node project, so I'm going to search for the node image. This is an official image provided by the Docker. If you are using Linux, you can just use this particular command to take a pull of this particular image. And while I have to do what? Let me just show you how to play around with the Docker images. So I just need to run this particular Docker image. I'm going to run a command, docker run node. So this is I have already I have this image already in my computer system. That's why it is not showing anything. Let me show you how we can check the existing images. Docker ps. This show all the running images, running containers, but we don't have any running container right now, so we can just use this command -a. ps stands for processes. Docker processes -a stands for all. So it will show all the processes which was on my computer system. So you can have a look. These are related to a project. These all are related to a project, and I have configured this node node image previously. So I can show you how to work with this. So let me just docker run php. So we are doing what with this command? We are just taking pull of this particular image from the Docker. If you have already this image cached in your system, then Docker will not download it. Otherwise, Docker will download it from the Docker Hub and then run it on your system. So just have a look. Unable to find the image locally. It's not cached, and it is downloading the PHP image right now to our system. I'm not doing this with the help of the Docker Hub and yeah, by configuring the Docker file. These are the predefined images, and we can download these images as per according to our requirement. But if we need to create our own images, we can do that with the help of the Docker file. I'll show you how we can do that. Let me just show you. If we are going to run Docker PS here, it's not a runnable image. It's not running right now. It's just cloned into our system. We can have a look to this particular image with the help of PSA command. Have a look. We have this container ID. Image is PHP command. Like if you want to just check, created 30 seconds ago, exited because yes, we don't have anything into this image configured, nothing. So that is exited automatically. And if we provide a name to our image, then it will be displayed over here. Otherwise, Docker provides a like dynamic name to every image. So this is just like just a sample image. We can remove Docker RM the container ID. We can remove a particular container from the command line itself, as well as the Docker desktop users can delete it from the Docker desktop also. So here we don't have any kind of PHP container right now. And if I have a look here, we have these images in our local system, that is Node. If you are using desktop version, you can directly remove that particular image from by clicking on the remove button. You don't have to use command line, but all the Linux users, you have to remember all the commands related to the Docker. So now let me show you how to create a Docker file. Now always we have to mention the from keyword here. From which image we have to mention the base image from where you are creating your Docker file, and you are creating an image. So obviously I have created a node project, so I'm going to take it from the node image. This command is telling Docker that you have to create an image with the help of the node image, which is available on Docker Hub. After that, we can use a copy command here. Copy is what? I have configured one thing here, that is package JSON server file and a public folder, which is mentioning, which is just having a style. And I have to do what? While we are creating an image, what we should remember one thing, that we are just copying all the files of our current working directory, which is on our machine right now. We have to copy all those files into the directory which is in the container after that. So if you think that you are making changes into your machine's file and that can be reflected to the image directly, so that won't happen. So by using copy command, what we are mentioning, that copy all the files, dot is giving command to the Docker. You have to copy all the files which is here in the working directory, and copy it to the app folder, whatever. Yeah, this is your custom name. You can give the custom name. You can give like project name. Over here we can just we were talking about the project of Superior CS. So we can give any name to that particular folder. So what we are giving a command from here is like you have to copy all the files to the Superior CS folder of the container of the image. After that, obviously, when we are just running a particular node project, our first command is what? npm install, to install all the dependency files, right? So I just given a command to the Docker that you have to run npm install command. After that, run, we prefer node server.js. We run like this, no? we run a node project like this. So this is what, this is a Docker file, and we are giving instruction from this Docker file to the Docker right now. So Docker is going to do what? Docker is cloning an image from the Docker hub that is related to node, and after that Docker is copying all the files and folders of our current working directory to the superior CS folder. After that, after copying all the files into the folder, then Docker is going to install npm run command, npm install command, and after that node.js. But now we can mention one more thing here, that is work directory. We can provide a particular path inside the container where I just want to place a particular, my project. So what we can do here, we can mention the work directory using the work dir command in app, and then we don't have to mention this. Okay. So our working directory is app, and we are going to copy all the files into the app. Working directory, we are mentioning this directory because when Docker is going to run this npm install command, that will run this command inside the app directory. If we don't mention this line, then Docker don't have the path where Docker have to install the npm dependency. After that, we can do one more thing here. We can, if we want to run multiple commands over here, so we can mention that in the array. That is, we have to write node first. After that, we have to write server.js, and if you have any kind of we can configure the node project to run npm run watch and npm run dev as well. So you can mention like this in the inside the array. So this is our Docker file actually. And now let me just remove the node modules from here, because we are going to work with. Okay, so now one more thing over here we have to mention. Right now the container is not going to run directly on our local host. As I show you, like our current project is running on localhost port number 80. So if I run this, let me just open. So we can use docker build dot to build an application from the image and to run a Docker. So it is displaying that they have created a working directory app, copying all the files to the app. They have installed the run npm install command, and now they are running node.js, node server.js, and we have only one process left here for the Docker build. It is taking a little bit time for the first time. After that, if you are creating build again and again, it will not take that much time, because it will check the cache first. So we have to use expose keyword with the port number, whatever you want to run on with your container. If you want to run your container on 3000, you can mention 3000 over here. But if I'm going to run by this command, the entire project, it will not run my container on this particular port with this command only, because for Docker file, expose 3000 is only a documented concept. Docker is not working on the expose 3000 command right now. Docker will not run your container on 3000 port, and to run your project on 3000 port, you have to change your command to run a container. That is okay. Our next command should be docker run our container ID, which is not built yet. It is taking a little bit time. Docker run container ID. Let me show you. Let me show you a sample container ID then. Okay, Docker run container ID. So it is doing what it is. Okay, it is running successfully. Let me just have a look. No. Okay, it's up. So this is our a container. We can like all thing is configured into this container, so I can't show you like how is it work, how it's working. I should have to like perform these steps first. I know because it takes a little bit time for like when you are running this particular command for the first time only. Okay, let me explain the further slides then. I'll have a look to this if it get configured on time, then I'll explain the things accordingly. If otherwise, we can have one thing in our mind whenever we have to run a particular Docker project, we have to use this command docker run -p, which is used to mention the port which should be exposed on the local host, because our container is a standalone environment. It is not connected to our machine. So if you have, suppose if you have Node version 14 in your machine and you have installed Node version 18 from the image, so it will be separated. I can show you this, like if I'm going to uh, run docker run node node is getting stopped. IT node. Okay, now we can check the version here. That is, this node image is having 18.2.0. And if I talk about my localhost nodes version, so you can just have a look. 14.17.6. So Docker is not dependent on our machine completely. Docker is a standalone environment, Docker container. So if you have some kind of software which is not installed on your system and Docker require that softwares, you don't have to install those softwares manually onto your system. You just have to use the Docker command to build your container, build your image, and you can work like according to your Docker containers only. So let's I'm going to explain a little bit more about your here we have some kind of commands which I mentioned. I explained Docker build command, which is building an image right now, not completed. We can run a like container with the help of the Docker run container ID command. After that, if you want to expose a particular port to the local host, you have to mention the local host port. If you want to use same ports for the both things, then you can mention 3000, colon 3000, then your container ID like this, and you will be able to run your container application into your local host. After that, you can stop a container by using the docker stop container ID command. After that, this is just a summary what I have explained before. So I just like want to mention that whenever we are working with the images, suppose we have created this image and we want to make some changes into our server file, like we have added this thing, and you want to like execute this change into your image, you can't execute this change directly into the image. You have to rebuild your application, because according to the Docker file, whenever you have built your application, Dockerfile has done what? Dockerfile has copied all the folders and files to the app folder actually. And if you made some changes into your files, then it will not be getting into the Docker image directly. You have to rebuild the application again. Then your like the entire changes will be get into the application, and then you will be able to see all the changes like into your application. So this is the summary right now, whatever I have covered in the previous slides. In like when we talk about an image, we have our code on our system, on our local system, that whenever an image has been built, has been created, our code should be entered into the image using Docker file, and an environment to run that particular code has been built according to our commands. After that, whenever we are talking about a container, then we can run multiple containers from a single image by running little bit command. So container is what? Where our code is running exactly within that particular environment, which is defined in the image itself. So you want to ask any question with this? What we have in Docker volumes? Docker volumes are what? Docker volumes are exactly uh, the the folders and files in our system, not the folder and files in the Docker images or Docker containers. We can do what? Docker is providing a powerful tool to us to communicate between the files between Docker container and our local system. So we can mention the path of that particular file and the folder in the volumes when we are configuring Docker into our application. These are the exactly volumes. Networks is what? Networks is something like we are doing what? We are just exposing our entire application to the www. Suppose you want to use any third party API into your container. Suppose you have to use Facebook login functionality, Google login functionality. You have to fetch third party data from the third party API. So to do so, to allow your container to communicate with the World Wide Web, you have to define networks into your Docker application. After that, we have last but not the least, that is Docker Compose. I'm just explaining this is a little bit because Docker is a huge topic and I can't cover all the things in a single slide. So I'm just giving you an overview over here. We have Docker Compose here. Suppose we have to divide our application into these multiple modules. That means we have to create multiple images, multiple containers into our application. Then this is a challenge for us to run each container by giving its ID, to run each images, and to perform certain steps on the every container. So Docker is providing Docker Compose tool to us, through which we can do what? We can run all the images by using a common command, that is I can mention it over here also. That is Docker Compose build. Sorry. When you are going to use this command, so Docker Compose is doing what? Is building all the images by using one command only. You don't have to build different containers separately. After that, you can use Docker Compose up command to run all the containers with each other. It has multiple options to run both of the commands with each other. We can discuss this later on. If anybody wants to learn more about the Docker, they can directly reach me out one-to-one directly, and I'll be available. I can share my schedule. I will be available to explain each and everything about the Docker. So these are some, this is an example of the Docker compose YML file. And now, thank you all.